In our last video, I showed how you could calculate a rate using a function, or a stored procedure could have done the same thing. You'll remember I passed in two parameters. One was basically an old value and the other was a new value, and it spit out the rate increase or decrease between those values. So the equation was new minus old divided by old times 100, and that's the percent either increase or decrease. So that's useful when we're talking about like a stock increasing, a currency value increasing, or like the inflation rate going up or down. In this video, I'm going to just use CPI as an example. So instead of using a function or a stored procedure, I'm going to use just a basic select statement. So you'll remember the code we built for the function, or even if it was a stored procedure. In this case, we're just going to use 3 lines of code, a simple select statement in the end. So this is going to assume that we have a table, and we don't need to worry about the table name, but we're creating a table, and this is the most important part of this, most important piece of this table, that there is an identity field, rate ID. We call this a small int, but it increments by 1 and it starts at 1. And of course it increments by 1. Now there's going to be a time value here. In this case I'm just going to use month, and I'm going to have the month January, February, March, April, May, etc. And then the value. This is what we're going to try to calculate our inflation rate off of using the CPI value. So you'll see that I've inserted into this table, create the table, insert into it, and it inserts the CPI value. For instance, in January is 2.3. Union all is just a kind of a, I don't want to say a fancy way, but it's kind of like selecting multiple values. It unions those values in a table. So, for instance, just to show you what this all looks like, there we go. So that's our value. So here's our rate ID, here's our rate month, and there's our CPI value. In fact, one second, let's just go ahead and put that on there. Okay, so it broke and stopped there. Okay. So when we're calculating a rate, the very first step is we're going to be referring to our identity fields. Or our identity field, I should say. And the biggest part of calculating a rate is we are going to do a self-join, I should say. Now, there are a lot of people who program in SQL that I have met that do not, and also that are data scientists that do not know that you can do a self-join. And this is one of the most useful tools to use when dealing with calculating rates or having a complex algorithm in which we're referring, let's say, to two values. So for instance, our goal is to get the rate of inflation from January to February, from February to March, from March to April, from April to May, and from May to June. And these are the CPI values. So you can see like CPI increased from January to February, 2.3 to 4.2. Well, what was the rate of increase? In February, the CPI value was 4.2, and it decreased in March to 3. So if we look at this here, we'll see that we did a self-join, and we're going to be using the value to calculate the rate. But right now we're just going to look at the ID fields. So our R1 rate ID and our R2 rate ID equal each other. But our goal, because this is going to be the old value, and this is going to be the new value, and remember our equation is new minus old divided by old times 100. That's our equation that we're basing this off of. Here, let me put that in the notes. New minus old divided by old times 100. That's our equation. That's what we're basing it off of. That means that since our old is 1 here, we need our new to be 2. Because this is January, this is February. This is February, this is March. This is April, this is May, this is June, and so on and so forth. So we need our old value to equal a higher new value. Right now, when our old value is 1, our new value is also 1. So essentially what we're doing here is we're using algebra, and we're saying 1 equals 2. But we need this to equal 1, so how do we make 2 equal 1? We subtract 1. And as you can see, this is what they refer to as, or this is what can be called relationship algebra. The relationship here is that when this is 1, if this is going to be 2, which is what we're trying to make it, in order for them to equal each other, what we're going to do is we're going to subtract 1. And you'll see, when our old value is January, our new value is February. Or basically, when our old value is 1, our new value is 2. You would see this if I produced the months, but I'm not going to. So, now we have our ID fields aligned exactly where they need to be with this join. So, we can just apply our algorithm below. New minus old divided by old times 100. So what's our new? R2. And it's the value, that's what we're after, is the CPI value. And we will subtract that from, R1 dot CPI value, and we will divide that by R1 dot CPI value, and we will multiply that times 100. And I'm going to do order of operations, just some basic math here, so that the computer knows what to take first. And then finally that, and I'm going to call this the monthly inflation rate. Okay, and you can see the inflation rate, growing and shrinking. And as I said earlier, we're going to make it to where it's 3 lines of code. So in order to make it 3 lines of code, there we go. We've accomplished the exact same thing that we did in the function. We have, except instead of having a function or stored procedure, this right here is our line of code. We're using the ID fields to produce these different values. But notice that we're using the exact same table. We're not joining another table. We don't create another table. I've seen people use rate calculations with the select by doing group bys, by using 3 or 4 different tables. None of that's necessary. With 3 lines of code, as long as your relationship algebra is correct here, you can actually create a rate with these 2 values.